Let's talk about the criteria that are needed to be fulfilled by the materials before getting selected as the appropriate material. So first thing is the wire preload. The wire that is being used must be strong enough to bear, like we need to fix the wire on the box, and it must be strong enough to be there. So this is the data that is showing you a few of the properties of the wire. Like this is the ultimate tensile strength, bulk density of the wire, and this is the the maximum preload tension that a wire can bear. This is for the 24 micrometer of the diameter of the wire, and this is for the 34 micrometer diameter wires. We can see that beryllium, this is the range. Tungsten seems to have very good ultimate tensile strength. Like the carbon is being used as the appropriate material right now, but tungsten is quite strong. Why is it selected? I'll walk it in the next slide. Walk it in the next slide. But let's see that the carbon is quite good. The tungsten is quite good. Iron has a quite nice ultimate tensile strength, and the beryllium is also quite good. So the copper has like a little bit lower of the ultimate tensile strength. So it is kind of rejected here already. It is rejected here. So this is the thing that the tungsten seems to be very good, but there are other criteria that we need to discuss, that we need to for a buyer to fulfill those things in order to get selected as the appropriate material. Another thing is the deflection of the wire. Like whenever it moves, it gets deflected. Alright. We can see that this is a straight wire, and when it is going to move, because of inertia, it is going to get deflected like this. So the wire must give us the least deflection, and that deflection is shown with this formula. Like there are multiple factors that are involved in the deflection of the wire under constant acceleration. Like the length of the wire is one of the things, length of the forks is one of the things, and then this is the preload tension, and the linear mass density of the wire is also affecting this deflection of the wire when it moves under constant acceleration. So all the materials must be appropriate for deflection as well. Like we can see that in the previous slide I showed you that the wire interacts with the beam and it gives us the beam profile. But if it's deflected, it can give us a normal beam profile. So it must have the least deflection. It must be straight in order to give a perfect beam profile and a good beam profile. So the deflection must be the least. This graph here shows data about the deflection of the wire and with the preload tension. Alright, the preload tension is actually the tension in the wire when it's installed. There is no load, there is no external pressure, but it's installed. So in order to decrease the deflection, we need to screw it tightly. So the more tightly it's screwed, the preload tension will increase and the deflection will decrease because it will be skewed tightened. So here's the data that is showing that this is the tungsten that was the best candidate before on the basis of the ultimate tensile strength. But in the deflection, it is showing a huge deflection. Like even after tightening up to this value, it is giving us this value of the deflection. So the tungsten is deflecting a lot. We cannot use tungsten. So with the copper we know that I showed you it has a very low tensile strength. It cannot be used. So we can just remove the carbon from the list. Iron and titanium are very dense. All right. With this formula, we need to have very high preload tension and lower mass density of the materials. So, but the iron is showing a quite good with the iron, like this is the iron, it is quite good, but it is very dense. Iron and titanium, both of them, they are very dense. We can see that. So they cannot be used as the material in the scanner. So what are left are the carbon and the beryllium. So this is the carbon, it is showing very less deflection, and the beryllium is also showing very less deflection. So they had a quite good ultimate tensile strength as well. So that is why carbon and beryllium are the only candidates that are left for the selection of the wire in the wire scanners. That's again, so the competition is, all the competition is left between carbon and beryllium. So the last criteria that is going to select the best candidate, the best material,